their security posture across platforms like AWS, Azure, and Google Cloud, while also exploring how generative AI can revolutionize and how we predict and prevent threats. For over a decade, I've had the privilege of training and collaborating with cloud architects, DevOps engineers, and security leaders across the globe, helping them design secure, intelligent, and automated defense systems, which can adapt to today's evolving cyber landscape. What drives me is one simple belief: security should not just respond to attacks, it should anticipate them. And that's exactly what today's session is about. Moving from reactive to predictive cybersecurity and exploring how AI is redefining the future of cybersecurity. Let's imagine this. It's 2 a.m. on a Sunday. Your SOC dashboard lights up red. A critical alert. An attacker has already been inside your environment for 6 hours, quietly exfiltrating data from your S3 buckets and lateral moving through Azure AD identities. Now here's the question. Do you react, or could you have predicted this? This is the fundamental shift we are talking about today. Moving from reactive to predictive cybersecurity. And AI is the force that redefines how we get there. So, in today's session, we'll look at how enterprises are operationalizing AI for predictive defense, from automated threat hunting to zero-day detection across multi-cloud environments. We would explore how companies like Seqrite, CrowdStrike, and Palo Alto Networks are already living this transformation. Welcome to the new age of cybersecurity, where we don't just respond to threats, we predict them. Cybersecurity didn't start with AI. It started with passwords. Back in 1970s, we thought locking down a system meant having a login prompt that said, enter your password. Fast forward 50 years, and now we are teaching machines not just to detect attacks, but to predict them before they happen. 1970s, this was the age of mainframes. Security meant access control. Who could log in, who couldn't? We basically had if-then logic in our systems. If user is an admin, then allow, else deny. No intelligence, no context, just static rules. It worked until attackers realized that they could exploit the logic flows faster than we could write new rules. Then we had 1980s to 90s. That's the age of viruses and antivirus software. We entered the signature-based era, where we matched files and network packets against known malicious code signatures. It's like the wanted criminal posters of cybersecurity. We could only catch attackers we already knew. If the malware changed a few bytes, the signature failed. This is still how traditional antivirus engines on the endpoints, even today, detect known threats. Then, 2000s, the heuristic detection. We started getting smarter in 2000s. The heuristic systems emerged. These looked for patterns of suspicious behavior instead of exact signatures. For instance, if a process was writing to system 32 or encrypting many files, then that raised a flag. This is the foundation of modern intrusion detection system and firewalls. which analyze traffic heuristically. Today, we do have a lot of services like GuardDuty, Azure Defender for the cloud, which are built on the same principle, which is rule-based behavioral detection, but definitely at a massive cloud scale. In 2010s came the big data revolution. With logs pouring in from thousands of devices, we started using statistical models to spot anomalies. Instead of asking, is this packet malicious? We asked, is this packet normal for the system? If a developer in India suddenly logged in from Germany at 2 a.m., the anomaly detection system like Splunk, QRadar, Azure Sentinel, they flagged it. But anomaly detection had one major flaw: alert fatigue. Analysts were drowning in false positives because the models didn't understand the context. Then, 2020s, we have the AI ML powered security. This is where machine learning transformed cybersecurity. Instead of relying on human defined rules, AI began learning what normal looks like and adjusting dynamically. For example, Messi, it uses machine learning to detect sensitive data exposure in S3 buckets. Microsoft Sentinel, it applies ML-based diffusion analytics to correlate multi-cloud signals. And then we have agentic AI and predictive security. And this is exactly where we are heading. The next wave is agentic AI, where autonomous agents like tireless cybersecurity analysts, they hunt the threats proactively, remediate the misconfigurations, and even collaborate across multi-cloud environments. For example, an agent in AWS could detect an EC2 compromise, automatically revoke the IAM keys, and inform an agent in Azure to check for lateral movement. This isn't science fiction. It's happening now. CrowdStrike's agentic security platform and Microsoft's Copilot for security are already taking us into this future. So in short, cybersecurity has evolved from static rules to self-learning systems. We're not just building secure systems anymore. We are building systems that can think, learn, and fight back. If AI can now detect, respond, and predict the threats autonomously, where does that leave us? The human defenders? Here's the question that I ask every SOC team I work with. Do you fight fires or do you forecast storms? That's the real difference between reactive and predictive security. Reactive teams are firefighters. They wait for alarms, rush in, and try to limit the damage. Then we have the predictive teams. They are the meteorologists. They anticipate, model, and prevent the disasters before the first drop of rain. So, as I said, the reactive security, which is the firefighting model, we have alert overload. In a typical SOC, analysts face over 11,000 alerts per day across tools like SIEM, EDR, firewalls, and threat feeds. Yet, over 50% of them are false positives. It's like trying to find one real needle in a haystack of decoys. In one of the AWS environments that I have worked with, the Security Hub dashboard showed over 200 guard duty findings, but only two were actually relevant. The rest were benign anomalies. That's alert fatigue at scale. The next issue is manual investigation. It's the triage nightmare. Copying data from CloudTrail, correlating all your IAM logs, pulling your VPC flow logs, and manually tracing the incidents across cloud and on-prem. This can take hours or even days. And more the tools that you add, obviously the slower it gets. And I remember when one of the hybrid Azure AWS setup, it took 72 hours just to trace a lateral movement because the incident spans Sentinel, guard duty, and the legacy SIEM that didn't talk to each other. Then, delayed response. Statistically, it takes 200 plus days for most organizations to detect a breach and another 70 days to contain it. That's like discovering an intruder months after they have stolen your house keys, right? Then, damage control. By the time we act, the damage is already done. Your data exfiltration, ransomware impact, or privilege escalation. At this stage, security becomes recovery management, not risk prevention. What is the result? Higher cost, longer downtime, regulatory penalties, and most expensive of all, loss of trust. Now, think about the predictive security, which is the proactive model. First, proactive hunting. The AI models continuously scan for weak signals, things that humans might miss. For example, Amazon Detective. It correlates guard duty findings and VPC logs to spot potential reconnaissance patterns before they escalate. In Azure Sentinel's Fusion Analytics, it uses machine learning to detect multi-stage attacks automatically. Then, automated correlation. Let me tell you, this is where AI shines. It breaks the data silos. Instead of humans cross-referencing logs, tools like Palo Alto Cortex and Microsoft Sentinel KQL rules, they use NLP and machine learning to connect the clues from millions of records in seconds. For example, if there's a login from a new country, coincides with the new IAM role assignment and an S3 policy change, the system is going to correlate those as one potential insider threat, not three separate benign events. Then, rapid prevention. When AI detects a probable threat, it doesn't wait for approval. It acts. It isolates the compromised EC2 instances, revokes the IAM credentials, blocks the public S3 access autonomously. In predictive setups, the incident response happens in seconds, not days. Then we have agentic intelligence. This is the 2025 frontier, the agentic AI. Imagine security agents that self-learn and coordinate across platforms. An AWS AI agent is going to be isolating an instance, notifies an Azure agent to check for lateral spread, and logs the entire event in ServiceNow, all without human intervention. What is the result? Reduced risk, optimized resources, and minimal business impact because security becomes self-healing. The best difference isn't reacting faster, it's anticipating smarter. Reactive security asks what just happened, but predictive security asks what's about to happen and how do I stop it? And that's the shift AI is enabling from human dependent reaction to autonomous prevention. Here's something that I want you to imagine. You walk into your SOC, and instead of a wall of red alerts, you see your AI assistant saying, "Good morning, I've detected an abnormal data transfer, verified it as a test workload, and adjusted the firewalls accordingly." That's not the future. That's where cybersecurity is heading. The key to this transformation lies in three layers. We have the foundational layer, the AI ML foundational layer. Then we have the generative AI layer and the agentic AI layer. Each building on the other to create a defense system that just doesn't react, but thinks, learns, and acts. So, what is this AI ML foundation layer? This first layer is like the nervous system of security. It senses, observes, and detects. Everything we know about machine learning in cybersecurity starts here in this layer. Your anomaly detection, that's where ML began, analyzing logs, behaviors to detect deviations from the norm. For example, AWS Guard Duty or Azure Sentinel's analytics rules use machine learning to identify unusual patterns like data being downloaded at odd hours or new API calls from unexpected regions. It's like your smart doorbell noticing that the person at your door is not one of your family members, even if it's never seen them before. When we talk about behavioral analytics, this is user and entity behavior analytics. It profiles every identity, user, service account, or API and flags an unusual behavior. You can think of it as a behavioral fingerprint. So platforms like Microsoft Defender for cloud, they do this extremely well. When we talk about pattern recognition, this is where your supervised machine learning models shine, identifying known threats by comparing against historical attack patterns. It's what powers the endpoint detection platforms like CloudStrike, Falcon, and Palo Alto Cortex XDR. This is fast, accurate, and ideal for catching the known attack behaviors, but limited when the threats evolve. So this layer, the AI ML foundation layer, is great at seeing, but it doesn't understand. That is where the next evolution comes in. We have the generative AI layer. This is where cybersecurity becomes context aware. Instead of just detecting events, the system now understands and communicates them. So here we have this threat intelligent synthesis. Generative AI ingests and correlates intelligence from multiple feeds and dark web sources and creates contextual threat profiles. When we talk about automated analysis, this is where GenAI's natural language understanding comes into play. It just doesn't interpret them. Tools like Amazon Q for security or Microsoft Copilot for security can explain an event in plain language. So, examples like the IAM role escalation resembles a lateral movement pattern observed in last week's guard duty findings. That's context plus intelligence, which gives us the clarity that we need. Then comes content generation. Now imagine auto-generating your responses, your response playbooks. GenAI can write customized remediation steps for every attack type in the language of your tools. For example, it can generate a Terraform script to close the open security groups or to create a ServiceNow incident with detailed recovery steps. For example, it can generate a Terraform script to close the open security groups or create a ServiceNow incident with detailed RCA steps. That's AI moving from analysis to action guidance. But what if the system could go a step further? Not just actions, but execute them. That is where agentic AI comes in. So here we have the third layer, which is the agentic AI layer. These AI agents, they make their own calls. For example, isolating a compromised EC2 or revoking IAM credentials in milliseconds. They don't wait for human approval. They execute policy-based responses autonomously. Think of it as having a 24/7 digital SOC analyst who never sleeps or second guesses. Then we have self-learning. These agentic AI systems, they continuously learn from outcomes. If a past remediation was effective, it reinforces that action. If not, it adjusts its playbook. This is continuous optimization, similar to reinforcement learning in AI models. Adaptive response. This is the holy grail, the dynamic defense. Your cloud posture, it shifts automatically as the threat landscape evolves. So, to summarize, AI ML foundation layer that senses and detects. Then we have the generative AI layer, which understands and communicates. Then we have the agentic AI, which acts and adapts. Together, they form the three layers of intelligent defense, transforming cybersecurity from a reactive process into a living, learning, and autonomous ecosystem. This isn't automation. It's autonomy. Up until now, we've seen how AI transforms cybersecurity conceptually. But let's make it real. This diagram shows how predictive defense actually comes live on AWS. It's not just about detecting threats faster. It's about creating an intelligent ecosystem where AI-powered services detect, orchestrate, and automatically respond without human delay. So, in this diagram, you can see three layers. Here, we have the detection layer. Think of this as the sensory layer of your predictive defense, constantly scanning your AWS environment for anomalies, misconfigurations, and data risks. So here we have guard duty, which is your threat intelligence engine. It continuously analyzes VPC flow logs, CloudTrail events, and DNS logs using machine learning to detect suspicious activity like compromised IAM credentials, unusual API calls, or data exfiltration attempts. So, if GuardDuty detects API requests from an unfamiliar IP range outside your organization, that's a red flag. It automatically sends to Security Hub. We have Messy. Messy is your data guardian. It uses machine learning to discover and classify sensitive data. Things like the personally identifiable information or access keys stored in S3 buckets. If someone uploads a CSV file containing credentials to an unencrypted S3 bucket, Messy detects it instantly. Messy doesn't just find data, it understands why the data is sensitive, which is the key to predictive data protection. Then we have Inspector. Inspector scans your workloads, your EC2 instances, your ECR images, your Lambda functions for known vulnerabilities and common vulnerability exposures. This is where predictive AI plays a big role. Inspector continuously learns from exploit trends automatically, reprioritizing the findings as new threats emerge. So it's not static scanning, it's adaptive vulnerability intelligence. Now that we've detected something suspicious, what happens next? That is where orchestration begins. This layer connects the dots between raw detections and intelligent action. It's where context, prioritization, and automation come together. So here we have the Security Hub. Security Hub is your central nervous system. Your Security Hub is going to be aggregating the findings from GuardDuty, Messy, Inspector, and normalizes them using the AWS security finding format. The beauty here is instead of having 10 dashboards, you get a single unified view with machine learning driven insight scores, which would help prioritize what truly matters. Then we have EventBridge. This is where automation begins. Your EventBridge listens for events from Security Hub, like a GuardDuty unauthorized access IAM user finding, and triggers a response workflow. EventBridge rules act like smart neurons. They filter events, route them based on severity, and invoke actions, like notifying, isolating, or remediating. Let's say, for example, GuardDuty detects an EC2 instance, communicating with a known crypto mining IP address. Your Security Hub aggregates this finding, and your EventBridge is going to be triggering a Lambda, and Lambda will be executing the isolation workflow instantly. And this brings us to the third layer, where the action happens. This is your response layer, the hands of the predictive security. This is the automation powerhouse, the layer where AI and orchestration meet real-world impact. Here, your Lambda, which is supporting AI-driven automation, is going to be your automated incident responder. It runs Python scripts or AWS SDK calls that enforce your remediation logic instantly and precisely. It can isolate an EC2 instance by removing it from its subnet, revoke IAM access keys, or even disable a user account in response to a detected anomaly. When we talk about isolate, These are typical auto remediation actions. Lambda performs isolation, blocking, and notifications. Isolation is where it quarantines the affected resources. When we say blocking, it updates the security groups or WAF rules to stop the traffic. Notification, it sends alerts to Slack or SNS or Security Hub with details of the remediation. When GuardDuty flags an EC2 communicating with a malicious IP, Lambda automatically adds that IP to a network ACL deny list before the attacker can exfiltrate the data. So, your detection layer, we have GuardDuty, Messian Inspector, which senses the anomalies. Then in the orchestration layer, we have Security Hub, Event Bridge, and Lambda, where Security Hub and Event Bridge would be prioritizing and routing the finding, and Lambda would be remediating automatically via isolation, blocking, and notification. This is predictive defense, the AI-driven detection, orchestrated action, and automated resolution in seconds. This architecture is the backbone of predictive cybersecurity. It transforms your SOC from a reactive responder into an autonomous defender. AI doesn't just tell you what's wrong anymore. It detects, it decides, and fixes it before humans even know that there was a threat. So here's a real case study. Every great cybersecurity story begins with one challenge. That is data chaos. Let me introduce you to Secret, an enterprise cybersecurity provider. As the customer base and telemetry sources exploded, traditional detection pipelines just couldn't keep up. So they turned to AWS to bring AI-driven predictive defense to life. Secret is a division of Quick Heal Technologies launched in 2018 to tackle enterprise-grade cyber threats. They built an extended detection and response platform focused on AI-based threat analytics, basically a system that thinks like an analyst, not just reports like one. Their customers include healthcare, manufacturing, and all the BFSI sectors, where every second of delay in detection means millions in potential risk. Seqrite managed telemetry from hundreds, every endpoint, email gateway, and network center. And this is where the real pain started. They were processing terabytes of telemetry every single day. Log came from endpoints, cloud workloads, emails, and firewalls, all needing correlation. Traditional SIEMs simply couldn't query at that scale in real time. Just imagine millions of alerts from 20,000 devices. By the time an analyst sees a pattern, the threat has already moved. Second challenge was zero-day identification. How do you detect unknown attack patterns that don't yet exist in your rule base? That's where static detection rules failed, and why Seqrite needed AI models capable of learning evolving behavior. To solve this, they re-architected their detection pipeline using AWS Analytics and AI services as the backbone. This is where the architecture shines. It's a perfect marriage of big data analytics and AI inference at scale. So here is the solution. We have Amazon OpenSearch service. This is a real-time analytics engine behind Seqrite's anomaly detection. They used OpenSearch to run parallel queries across petabytes of security logs, detecting abnormal correlations in milliseconds. For example, an IP suddenly authenticating to multiple customer environments triggered a predictive alert even before an IOC existed. Then we have Amazon EMR. This handled the heavy lifting. Amazon EMR processed and transformed raw log data at scale, running Seqrite's proprietary behavioral analytics model on top of Spark clusters. The result? Continuous enrichment of the correlation engine, enabling pattern learning across historical data. Then we have Kinesis. This is the real-time stream ingestion layer. Kinesis collected data from all the customer endpoints, emails, gateways, and firewalls, pushing it into EMR and OpenSearch pipelines. It turned what used to be batch-based detection into a real-time event-driven system. Think of it like this. Kinesis is going to be bringing the data, EMR refines it, and OpenSearch thinks. Together, they create a pipeline which is going to be detecting an attack while it is still in motion, not after it's done. This is where it all paid off. Measurable, business-grade results. Seqrite's system could now process and analyze events in milliseconds, detecting lateral movement or command and control activity before escalation. The AI layer, it started recognizing early stage indicators of compromise, patterns that might look harmless individually but collectively hinted at pre-attack behavior. For example, a series of small, harmless IAM permission changes was flagged as a precursor to privilege escalation. And here's the number that makes every CISO smile. Threat detection accuracy improved by 85% within 6 months of deployment. That's not theoretical. It's validated by operational telemetry and reduced false positive rates. This case study perfectly illustrates what we've been discussing. AI doesn't replace the analyst. It amplifies the analyst. By leveraging AWS services like Kinesis, EMR, and OpenSearch, Seqrite moved from being a reactive security vendor to a predictive security intelligence provider. Seqrite didn't just modernize detection. They redefined what speed and scale means in cybersecurity. Now, let's switch perspectives from cybersecurity vendors to real-world operators. Imagine being the CISO of a major international airline. Your flight systems run on Azure, customer data sits on AWS, and your operations are still connected to on-prem servers at airports worldwide. Now, imagine trying to detect and respond to a security incident across all three in real time. That was the challenge this airline faced. And it's exactly where Microsoft Sentinel came into play. This organization is one of the world's largest airlines, processing millions of passenger reservations, flight schedules, and payment transactions every single day. The challenge? Their systems were massively distributed. On-premise mainframes at airport hubs, Azure-based web and data services, and AWS environments for analytics and booking APIs. Security wasn't just about defense. It was about flight continuity and compliance. If a single airport login system goes down or gets breached, the ripple effect isn't minutes. its global flight delays. This clearly picturizes the multi-cloud security nightmare. They needed unified visibility because threats weren't confined to one platform. A lateral movement could start from a compromised EC2 instance and end with privilege escalation on an on-prem AD domain. They needed a single pane of glass to track it all without losing context. And airlines runs on milliseconds. Ticketing systems, boarding, and customer data are all real-time operations. So the security team, they had to detect and isolate a breach before it could impact the customer transactions or compliance systems. They couldn't afford a traditional SIEM's lag. They needed AI-assisted instant response. And that is where Microsoft Sentinel became the game changer. Sentinel Cloud Native SIEM became their command center, unifying logs and telemetry from Azure, AWS, and on-prem servers using built-in connectors. The airline used Sentinel's AI-powered correlation engine to detect cross-cloud patterns like an AWS IAM access key being used to log in from Azure virtual machine. That's a classic indicator of compromise that would have been invisible before Sentinel unified the data. So we have the KQL analytics rules. Custom query language powered the detection logic. Custom analytics rules were written to detect unauthorized logins, lateral movements, and privilege misuse within reservation databases. For example, if a user from the ground operations team suddenly accessed customer booking APIs or performed high-frequency PowerShell executions, Sentinel flagged immediately as normal. This is where automation sealed the deal. Your logical applications, they acted as the response brain, triggering immediate isolation of the affected virtual machines or users. Ticket creation is ServiceNow and alerts to the SOC team through Microsoft Teams integration. So instead of human analysts scrambling to respond, the workflow was automatic within seconds. You can say, in a world where a ransomware attack spreads in minutes, logic applications responded before an attacker could encrypt the second system. According to the Forrester Total Economic Impact Study, the airline achieved 201% return on investment, thanks to the reduced breach impact, faster containment, and fewer manual hours spent on triage. This wasn't just about better defense. It was financially transformative. The metrics speak for themselves. The mean time to detect reduced by 60%, and the mean time to respond improved by 75%. That's the difference between losing the data and preventing data loss. Microsoft's vision for Sentinel reflects what matters most in cybersecurity: clarity, scale, and real-world impact. The multi-cloud visibility has transformed our security operations. This isn't just a marketing code. It's the voice of a CISO who just turned chaos into control. Whether your workload runs in AWS, Azure, or on-prem, Sentinel proves that AI doesn't just watch your cloud, it connects them. Now, let's talk about one of the toughest jobs in cybersecurity, being an SOC analyst. Imagine walking into your SOC on a Monday morning and being greeted not by your teammates but by 10,000 alerts from overnight. You know 98% are false positives, but still you need to check them all. Now imagine doing that every day, every week, every quarter. That's the world many enterprises lived in until AI-driven SOC transformation with Palo Alto Cortex XSIAM came into play. Palo Alto Networks, as we all know, is one of the global leaders in cybersecurity innovation. Their Cortex XSIAM, their Cortex Extended Security Intelligence and Automation Management platform was built to solve a very human problem, SOC burnout caused by alert overload. This case study isn't about one company. It represents 6 major global enterprises that transformed using extended security intelligence and automation management, AI-driven analytics, unified data model, and automation-first design. You can see here organizations adopting AI-driven SOCs have been growing exponentially since 2020. By 2025, AI-powered SOC will no longer be futuristic. They'll be the default operating model for enterprises worldwide. The challenges are the SOC pain points. We have the alert fatigue. Analysts spend more time dismissing false positive than investigating real incidents. It's like having a smoke detector that goes off every time someone makes toast. Eventually, you stop listening, and that's when the real fire starts. The second challenge was manual triage. Analysts, they had to pivot across 10 to 12 tools, threat intel feeds, just to piece together what was happening. This caused long mean time to detect and mean time to respond, often stretching into hours or days. AI doesn't just speed this up. It eliminates the bottleneck entirely by correlating the data in real time. And this is exactly where Cortex comes into picture. The Cortex Extended Security Intelligence and Automation Management System flipped the traditional SOC model on its head. It's supported with AI-driven analytics. At the heart of this system lies 1,300 plus AI models, continuously learning from telemetry across endpoints, networks, and cloud sources. These models detect threats using behavioral baselines, not static signatures. For example, identifying an insider threat based on deviations in file access patterns, even if no malware was present. Unified data lake, this isn't a secret sauce. A centralized security data lake that can ingest and analyze 70 times more data than legacy systems. Instead of relying on sampled or summarized logs, this system consumes raw telemetry across the enterprise, enabling cross-domain correlation at scale. When you unify data, you don't just see incidents, you see relationships between incidents. And that's what AI thrives on. The Cortex System Automation Engine proactively hunts for threats using customizable bring your own AI models. So if an organization's threat landscape is specific, say a financial firm or a healthcare provider, they can train and deploy their own machine learning models on top of XSIAM. And that's SOC modernization in action. Not just managed by AI, but customized by AI. So what was the result and impact? 99% reduction in resolution time. This is the headline metric. By automating data correlation, triage, and response, median time to resolution dropped by 99% across all 6 enterprises. What once took hours or days was handled in seconds without sacrificing accuracy. Automated response. The AI engine, it doesn't just alert, it acts. Cortex XS IAM triggers automated playbooks that isolate the compromised endpoints, disables suspicious user accounts, and contains the lateral movement all before the analysts even open the dashboard. That's predictive SOC automation, where AI neutralizes the threat before humans even get the alert. So here you can see a donut chart. You can see here that there is a 99% reduction in resolution time. Again, this is not theoretical. It's validated across production environments where AI continuously learns, correlates, and self-improves. Success lies in the AI-driven automation-first capabilities within Extended Security Intelligence and Automation Management Platform. Advancing better insights, more correlations, and creating a proactive security posture. This isn't about adopting a tool. It's about adopting an AI mindset for SOC transformation. And this case marks a turning point in cybersecurity operations. So, AWS gave us predictive remediation. Sentinel gave us multi-cloud visibility, and XSIAM gives us operational AI at scale. Let's fast forward to the future of SOCs, where human analysts no longer fight fires alone, but command an army of intelligent autonomous AI agent that detects, hunts, and responds at mission speed. This isn't science fiction. It's CrowdStrike's agentic security platform, a complete reimagining of the Falcon architecture for the age of agentic AI. If AWS taught us to predict, Sentinel taught us to unify, XSIAM to automate, CrowdStrike, it shows us how AI can act on its own intelligence. CrowdStrike has always been synonymous with cloud-delivered endpoint protection. But 2025 marked a turning point, with threat actors themselves beginning to use AI for offensive cyber operations. From deep fake phishing to autonomous malware, CrowdStrike knew that reactive defense wouldn't be enough. So they built something revolutionary, the agentic security platform, an ecosystem where AI doesn't just detect and recommend, it decides and executes. You can think of it like an air traffic control. Instead of one human controller manually guiding hundreds of planes, you now have a network of autonomous drones that self-navigate, self-correct, and alert the human only when the situation gets critical. That's exactly how agentic SOC operates. Attackers are now using AI to outthink the defenders. They deploy polymorphic malware that mutates in real time and uses generative AI to mimic normal user behavior. This makes the traditional rule-based or even static AI models to be obsolete because the enemy now learns and adapts faster than we can respond. When I say alert fatigue, despite all the AI investment, security teams, they were still overwhelmed. Thousands of alerts daily, many repetitive, many low priority. So the goal was clear. Move from AI-assisted analysts to AI-augmented operations, where Machine agents could handle repetitive triage, leaving humans to focus on strategic threats. And that's where CrowdStrike's agentic solution fundamentally reshaped the SOC. So here's the agentic solution, the threat AI. This is the beating heart of CrowdStrike's new Falcon platform. Threat AI acts as autonomous decision maker, synthesizing telemetry, context, and global threat intelligence to act independently. It doesn't just flag an anomaly. It correlates it, determines the intent, and executes the next step, like isolating an endpoint or suspending a suspicious process without waiting for human approval. If a traditional SOC, if they are the firefighters who sees the smoke, threat AI is the sprinkler that activates before the fire spreads. So, the autonomous threat hunting. Let me tell you, these AI agents, they don't sleep. They continuously query the environment, scanning the logs and systems at machine speed. In the past, human threat hunters wrote KQL or SPL queries manually. Now, agentic AI, it hunts proactively, writing and running its own queries, and even improving them based on outcomes. AI-enabled vulnerability management. This is where predictive intelligence meets patching. The system prioritizes vulnerabilities based on real-world exploitability, not just CVSS scores, and even triggers automated patch deployment across endpoints at scale. So now, instead of SOC analysts chasing alerts, they direct a fleet of AI agents that is going to do the chasing. 24/7 machine speed operations. The most impressive result. CrowdStrike's agentic SOC operates continuously, analyzing and executing the tasks at machine speed. Analysts act as commanders, not responders, guiding strategy while AI handles the execution. And also, automated malware analysis. Malware reverse engineering that once took hours is now done in seconds. The AI agents, they can reverse, classify, and compare the files instantly and auto-generate the detection rules for the next variant before it even appears. This graph says it all. Traditional detection took minutes to hours. An AI-powered system took seconds. And agentic AI brings that down by another 95% in response time. That's not incremental, that's evolutionary. So CrowdStrike shows us what's next. SOCs where humans drive intent and AI executes that intent at mission scale. This isn't replacing analysts. It's redefining them as strategic leaders of autonomous security ecosystems. In short, we've moved from predictive AI, AWS, knowing what's coming, proactive AI, Sentinel, responding instantly, agentic AI, CrowdStrike, acting independently. This is the frontier of cybersecurity, where defense becomes autonomous, adaptive, and always on. Now, let's bring everything that we've discussed, detection, orchestration, and AI-driven response, into one unified story. Imagine a real-world SOC operating in a multi-account AWS environment. Every second, it's flooded with signals, suspicious EC2 traffic, exposed S3 buckets, risky IAM keys. Now, instead of humans manually chasing every alert, AWS's predictive architecture allows these findings to flow autonomously through detection, orchestration, and remediation pipelines. So threats are not just found but fixed in real time. This journey begins with Amazon Guard Duty, which continuously monitors the AWS accounts for malicious activity, compromised instances, and unusual API calls. Guard Duty uses machine learning models and anomaly detection to flag things like EC2 instance talking to known botnets, IPs, root API keys being used in unfamiliar regions, or a potential crypto mining process starting in your VPC. In this workflow, Guard Duty would send these findings directly to the Security Hub for centralized visibility. So here